What if I told you that the key to living a longer, more vibrant life, the secret to having more energy, thinking with greater clarity, recovering faster from exercise, and genuinely slowing down the aging process, wasn't some expensive new supplement or a complicated biohack? What if that key was hidden right now inside of you, in structures so small they are dwarfed by a single grain of dust? You see, there are over 30 trillion cells that make up your body, and inside nearly every single one of them, there are microscopic power plants working tirelessly 24/7 to keep you alive and functioning. They're called mitochondria. For a long time, we knew them by their simple textbook nickname, the powerhouses of the cell. But as science has peeled back the layers of cellular biology, we've discovered that they are so much more than that. They are the engines of human life, the regulators of our health, and the gatekeepers of our longevity. Today, we're going to shrink down billions of times smaller than our normal size to journey deep inside the human body. We're going to explore the secret life of your mitochondria and discover why understanding them might be one of the most important things you can do for your health. To understand mitochondria, let's first imagine one of your cells as a miniature, bustling city. The nucleus is City Hall, issuing all the orders and holding the master blueprint of your DNA. The cell membrane is the city wall, controlling what comes in and out. The proteins are the tireless workers, building, repairing, and transporting everything. But no city, no matter how well organized, can run without power. And that is the mitochondrian's job. They are the power plants, providing the electricity for every single operation. The number of these power plants isn't the same in every cell city. It depends entirely on the city's energy demand. A quiet residential cell, like a fat cell, might only need a few, but a cell in your heart muscle, which has to beat reliably every second of your entire life, that can contain 5,000 or more. Your brain cells, firing off electrical signals to create your every thought, are packed with them. Your skeletal muscles, allowing you to walk, run, and lift, are also teeming with thousands of these microscopic engines. The sheer number of them is staggering. If you could somehow take all the mitochondria from your body and place them end to end, that chain would stretch for thousands upon thousands of kilometers. They are an immense interconnected network of energy production woven throughout your entire being. So, how exactly do they make this energy? The process begins with the food you eat. Every carbohydrate you consume is broken down into glucose, fats become fatty acids, and proteins become amino acids. These basic fuel molecules are transported into your cells and delivered to the tiny biochemical factories inside the mitochondria. The ultimate goal of this entire process is to manufacture one single miraculous molecule, ATP, adenosine triphosphate. You can think of ATP as the universal energy currency of life. It's like the dollar or the euro for your cells. Every single action, from a muscle contracting to a neuron firing to a cell repairing its DNA, requires a payment of ATP. At the very heart of this production is a process called the electron transport chain, located on the highly folded inner membrane of the mitochondrion. Imagine a microscopic assembly line. The fuel molecules from your food release high-energy electrons, which are then passed down this line of protein complexes like a hot potato. As the electrons move, they release little bursts of energy. This energy is used to pump protons across the membrane, creating a powerful electrical gradient, like water building up behind a dam. And then, at the end of the line, comes the payoff. The immense pressure from this proton dam is funneled through a molecular marvel called ATP synthase. It's a genuine rotating motor, a microscopic turbine that spins at incredible speeds, thousands of RPMs. And with every single turn, it takes raw materials and forges a molecule of ATP. Every heartbeat, every thought, every breath is paid for by these spinning turbines. For decades, this is where the story ended. Scientists believed mitochondria were simple batteries. But we now know they are so much more. They are sophisticated information processing hubs. They help regulate cell growth and communication. They carefully manage the cell's calcium balance, which is critical for nerve signaling. They are involved in producing hormones like testosterone and estrogen. They play a key role in our immune responses and controlling inflammation. Perhaps most critically, they help determine when a damaged cell should die. Mitochondria act as the cell's operations managers. They constantly sense the cell's health and energy levels. If a cell is under too much stress or is damaged beyond repair, the mitochondria can initiate a process of controlled self-destruction, making way for a healthy new cell. In many ways, they are the cellular decision makers. When they're healthy, the entire cell performs better. When they're not, the whole system suffers. And unfortunately, mitochondria are not indestructible. Over time and through our daily habits, we can impair their function. What damages them? The list might sound familiar. Chronic sleep deprivation, a sedentary lifestyle with little physical activity, smoking, poorly controlled diabetes, persistent low-grade inflammation, heavy alcohol consumption, even exposure to certain environmental toxins, and, of course, the process of aging itself. As mitochondria become less efficient, a dangerous two-part problem emerges. First, ATP production declines. You feel this as fatigue, brain fog, or slower recovery. Second, the energy production process becomes sloppy. It starts to leak, spewing out more cellular exhaust fumes in the form of highly reactive molecules called free radicals. Think of free radicals as tiny, ricocheting bullets inside your cells. A few are normal and even useful for signaling, but when they're produced in excess, it creates a state called oxidative stress. These free radicals start damaging everything they touch: proteins, lipids, and even the DNA in the nucleus. Most critically, they damage the mitochondria's own DNA, creating a vicious downward spiral of less energy and more cellular stress. This brings us to one of the biggest questions in human biology. Why do we age? A leading theory places mitochondria right at the center of the story. The mitochondrial theory of aging suggests that the slow, steady decline in the function of our mitochondria is a key driver of the aging process itself. As energy production declines over the decades, cells can't repair themselves as effectively. Tissues become less resilient, muscles weaken, a condition known as sarcopenia, brain function changes, and this systemic decline creates an environment where age-related diseases can take hold. Indeed, researchers have now linked significant mitochondrial dysfunction with a host of conditions, including type 2 diabetes, Parkinson's disease, Alzheimer's disease, heart disease, and age-related muscle loss. While they are not the sole cause of aging, their health is a critical pillar of how well our bodies age. But here is the most incredible, most empowering part of this entire story. You are not a passive victim. Your mitochondria are remarkably adaptable. They respond directly to the demands you place on your body. The single most powerful signal you can send them is exercise. When you push your body through aerobic exercise or resistance training, your cells sense a huge energy demand. Their response is to build more power plants. This amazing process is called mitochondrial biogenesis. You are literally telling your body to construct brand new, more efficient mitochondria. Good sleep is also non-negotiable. It allows your cells the time they need to perform critical repair and maintenance on these power plants. A balanced, nutrient-rich diet provides the high-quality raw materials they need for clean energy production. And managing chronic conditions and maintaining a healthy weight reduces the inflammatory burden that can damage them over time. While scientists are still studying how things like caloric restriction or intermittent fasting influence this biology, the core message is clear. Your lifestyle directly shapes the health of your cellular power plants. Inside every heartbeat you feel, every blink of your eye, every memory you form, and every step you take, billions upon billions of mitochondria are working tirelessly. They are the silent, microscopic engines that transform food into movement, oxygen into energy, and chemistry into conscious life. The better we care for these tiny power plants, the better equipped our bodies will be to stay healthy, resilient, and vibrant as we age. Because longevity isn't built by one miracle supplement or a single quick fix. It's built from the inside out, cell by cell, mitochondrion by mitochondrion, day after day. If you enjoyed this microscopic journey through the engine room of human life, subscribe to CellWise Health for more evidence-based explorations of the extraordinary body you live in.